Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to my classes. In this session, we are going to discuss about user datagram protocol. Nothing but UDP, one of the faster protocol which is working under transport layer. So before entering into the session, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has created a wonderful platform to serve the dedicated students just by providing top quality content. So to utilize this opportunity, just give your valuable admission into Unacademy using my referral code. Then Unacademy is going to take care of you till your examination completed. Dear friends, myself is Srinivasrao IS, having more than 15 years of experience in the GATE with the various subjects. Also had industry experience in the backend side, that is the database and the systems. So throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students got completed their post graduation from India's topmost institutions, IITs, NITs, Central Universities, and IIITs. You also can have such kind of wonderful opportunities to work with topmost companies and topmost PSUs just by taking proper guidance, tips, and shortcuts by the experienced educators. Any competitive examination which is having negative marking, there is a proper requirement of do's and don'ts that you are going to get only from the experienced educator. What kind of a mistakes you are going to do in the examination. So such kind of guidance is going to be provided by the educators on behalf of an academy. So dear friends, to get the admission into an academy, there are two types of programs. One is a plus program, the other one is iconic program. So once you become a plus student, then you're going to see that unrestricted access where you can able to access everything whichever is there in an academy portal, like live sessions, live quizzes, mock test, and mock sessions, many other things which are there in the academy. And the second one is iconic. This is one of the unique program which consists of your regular plus program. Along with that, you're also having 1:1 personal coach. So dear friends, those who are already plus students, please migrate from plus to iconic, where you are going to have dedicated 1:1 personal coaching. So utilize this unique program which is offering by Unacademy. And dear friends, according to the subscription prices, so there is a long term and a super long term subscriptions are there. So first and second and third year can prefer for super long term, that's a 24 months. And second and third year students can prefer 18 month subscription. And current fourth year students can opt for 12-month subscription. Dear students and dear friends, by using my referral code, then you're going to get a maximized discount. So use my referral code, you're going to get a maximized discount. Apart from maximized discount, you're also going to get all my experiences and my old students' experiences, how they have got cracked the GATE examination with a very good percentile with a low rank. So after applying my referral code, these are the prices which I was discussing. And the second kind of program is iconic, where you are having a two types of subscriptions, 12 months and 24 months. So the super long term can first year and the second and third year students can opt, and fourth year students can opt for 12-month subscription. Dear friends, use my referral code to get the admission into Unacademy, and you see that you're also going to see that I'm going to be your guide. So whenever you are using my referral code, so after applying my referral code, then these are the prices you're going to see. So join into Unacademy and see that you're going to get the best from the top quality educators and dedicated educators especially. So educators, senior and experienced and dedicated educators you're going to learn. So please join under me using my referral code. Then I'm going to get all your learners list who are joined using my referral code, so that I can able to provide all my complete experience and all my complete knowledge sharing with you. If you are having any doubt, you may reach us just filling this form. Fill this form, then Unacademy is going to direct a member who can able to assist you to clear all your doubts. And Unacademy is successfully running many programs for CSE students. The channel name is Let's Crack GATE CSE. So just access this channel, subscribe this channel, and hit the bell icon for latest notifications and updates. Use my referral code to get the admission into Unacademy. So dear friends, to get the in-depth training and in-depth knowledge in the respective areas where you are interested, then you please join into Unacademy. So the free resources can able to help you up to some extent, but beyond that you want to learn and you want to see that a good rank you're supposed to get, then you need to take a subscription into Unacademy, because many kinds of things we used to discuss in the plus program and not on the free resources. So anyhow, however, the free resources are very useful to you to attain a good marks and to attain a good rank, but apart from that you want convert your admission into Unacademy just by using my referral code. Now let us start our today's lecture. I have one question here. So we know that the transport layer, especially whenever you are talking, it is running with the two important protocols, TCP and UDP. So this is coming with a 6 and this is coming with 17 as your protocol number. So you all may get a doubt that as we are having a TCP and why there is a requirement of UDP. First question. So there is one important thing I want to discuss. TCP is a slower. Why it is a slower? Because its data stream is in the form of a segment and it has to establish, first of all, get the connection, then you're supposed to transmit your data. That's why it is a slower transmission and it is a connection oriented. For example, in TCP, I want to have the communication between X and Y and Z and A. So here what is going to happen? X would like to send the data, X would like to send the data to Z, and X would like to send the data to A. Then there is a requirement of X with Y. There is a one TCP 1:1 connection required. X with Z, there is a one TCP connection is required. and X with A, there is a 1:1 TCP connection is required. For example, I want to transmit the X is a source would like to transmit to 1,000 nodes. And what is going to happen? The X is a need to establish 1,000 three-way handshake connections. 1,000 dedicated three-way handshake connections. So it is going to be very, very slower. That's why TCP is not fit for broadcasting and multicasting. I can do broadcasting and multicasting in TCP, but what is the problem? The only one problem is that for every node you are supposed to establish the connection, otherwise you cannot able to send the data. So that's why, my dear friends, the TCP is going to be very slower in this area. That's why TCP is very famous for 1:1 unicasting connections. So you want to have very faster data transmission, and we do not want to see that any kind of connection to be established initially before transmission of your data. In opposite direction, you prefer UDP, because TCP is a heavyweight. This is another one of the synonym for TCP. It is a heavyweight. Why it is heavyweight? Because it is a carrying 20 byte header and a maximum to 60 byte header. That's why every segment is have a requirement of 20 byte to 60 byte header. That's why it is heavyweight. But when you talk about that, I want to do broadcasting and multicasting, that means a node X would like to transmit the data to node Y, node Z, node A, node M, and node N. I don't mind. It can be N. I don't mind. I can able to do easily, because I do not want to see that any kind of connection to be established. So when you see that any kind of connection to be established, that then immediately your data is going to be passed to multiple numbers in a quick fair way. Why? Because I'm not establishing any kind of a connection, so the data is going to be transmitted to other side very quickly, even though you are having n number of nodes. So whenever you want to transmit to broadcasting and multicasting, then better you prefer UDP. And one more important point between TCP and UDP, TCP uses a single path. TCP uses single path transmission. But when you talk about, that's why it is a static, please understand. Why TCP is a static? Because it is using single path transmission. But whenever you talk about the UDP, it can have multi-path transmission. So what is a multi-path transmission? The datagrams can able to transmit via multiple lines. It need not follow a single line as your TCP. That's why UDPs are, first one, lightweight. Why lightweight? Because its header is a very minute. How much? Only 8 bytes only. Only 8 byte header a particular datagram has. And that too, it is a very faster. Why it is very faster? Because I can able to switch over onto multiple paths. I'm not going to wait for a serial execution like TCP. Now it is going to be done on multiple paths. Wherever path is available, the datagram can able to pushed. That's why they are faster, and it is a what? Dynamic nature. Why dynamic nature? Because it can able to traverse on multiple paths, not on a single path. And UDP is not require any kind of a connection. That's why it is, you say that, very faster, because I don't require any kind of three-way handshake protocol, especially for UDP. Now, what are the real-time examples of your UDP? UDP uses broadcasting, multicasting, real-time data, multimedia data, where we don't require any kind of connections. It's completely connectionless, the applications which I spoke now. like broadcasting, multicasting, and real-time data transfer and multimedia. They are all based on your UDP. That's why transport layer decided that some are secure transmission and some are fast transmission. So some applications comes under into fast transmission and some applications comes under into secure transmission. So when you talk about secure transmission, then there is a requirement of TCP. The one of the example which I want to tell you that HTTP is following TCP and many other protocols which they want to do TCP. Whenever you are talking secure socket layer, then there is a requirement of TCP. And you are preferring fast transmission, then when you prefer the fast transmission, then immediately the transport layer understand that don't prefer TCP because it's a slower and that too it is a connection oriented. You don't worry about what? Reliability. If you are not worrying about the reliability, better you prefer UDP. Whatever the works is doing by TCP, all the works can be done by UDP except reliability and except no flow control, except no error control. So some are limitations are there with UDP. So that's why your transport layer is going to decide based on your protocol standard. It is going to designate whether to work with the TCP or to work with the UDP. So almost all your application protocols are going to divide into two different categories like this. So whenever you talk about the application protocols and when you interacting with the transport layer, then it is going to direct you whether you are accessing through TCP or whether you are accessing through UDP. This number is a 6 and this number is a 17. So then if application layer is willing to do with the TCP oriented connection, it is going to establish the protocol number as a 6. And whenever application layer is used to interact the transport layer with UDP, then immediately put the protocol number as what? 17. So both are the standards of your transport layer only, and both are for end-to-end communication, and both are using with the what? Sockets. Both are using sockets only. So it also deal with the socket address. UDP is also going to deal with the socket address. So this is a brief introduction about UDP. Why we need a UDP in some of the applications, how the transport layer is going to divert from TCP to UDP in this aspect. Now, if you talk about some of the important points I want to highlight here. So UDP is suitable for a process that requires simple request response communication. And UDP is suitable for where you don't require any flow control, any congestion control, any error control, any kind of things, then you prefer UDP only. So UDP is suitable for a process where your inbuilt has internal flow control, error control mechanism naturally. We will say that UDP is a lack of flow control and a lack of error control and lack of congestion control. So UDP is a suitable transfer protocol, especially for multicasting and broadcasting. So let us continue some of the important points of UDP. UDP is connectionless. It's unreliable because connection is not established and it is working at transport layer. So why the UDP is so famous? Because it is a lightweight. So how I am saying that it is a lightweight? Because its a header size is only 8 bytes only. Even you are trying to send 65,536 bytes of data, my header size is 8 bytes. But if we look at in TCP, your header size is going to be 20 bytes. That's why as comparatively to TCP, UDP is lightweight. And why and when this is very useful? If a process wants to send a small messages and does not care much about reliability, then immediately transport layer is pushed to UDP only. So UDP packets called as user datagrams have a fixed 8-byte header, and UDPs are dynamic and faster. Why faster? Because its a header is 8 bytes. Why it's a dynamic? Because it can traverse onto multiple paths, unlike your TCP. Your TCP is a what? Single path transmission. And UDP is located between the application layer and the IP layer. We know. So at the top application layer, at the bottom internet layer. Now on behalf of transport layer, that UDP is going to work. And UDP packets are encapsulated into IP datagrams. So that's why UDP packets are encapsulated into IP datagram. So UDP is for unicast, multicast, and broadcast. But most of the cases we prefer broadcasting and multicasting. So whenever IP is transmitting on behalf of UDP, its context is UDP payload only. So UDP is very similar to IP, except that it's not a host to host. It's a what? End to end delivery. End to end delivery. So UDP does not provide error control, and UDP detects an error in the received packet using a checksum, and it is silently drop it. If at all checksum is corrupted, then immediately it silently drop. It's not usually used for a process such as FTP, because FTP is based on TCP, because it want to send a bulk data, not a smaller and shorter messages. So bulk data transmission you prefer TCP, and shorter messages you prefer what? UDP. So that's why UDPs are not for bulk data, it's only for what? Shorter messages. How much UDP can able to transmit is 65,536 bytes. Start with a 0 byte and ends with 65,535 bytes. This is including your lightweight header, that is 8-byte UDP header. So when you want to transmit a shorter messages, better you prefer UDP. So what are the limitations of UDP? So UDP limitations are, it's unreliable because no connection is established and no guarantee that data is pushed to other side or not, and no data guarantee access. It's unlike your TCP. These are all the limitations. In TCP, data is going to come in order, but here it may come in out of order because your data is going to come via multiple paths. So whenever it is coming via multiple paths, then the data is going to come in out of order. So receiver is responsible to reorder those data packets and data bytes. So no flow control exclusively, internal flow control you need, and no error control internally. You need to have internal control, error control, and no congestion control. No negative, and no positive acknowledgement concept. But in TCP, these are all positive. What are positive? It has got exclusive flow control, error control, congestion control, timer management, acknowledgement, positive and negative, and reliability. So when I say that there is no acknowledgement, that's it. We are in a question mark whether it has gone successfully or not. So these are all the limitations to your UDP. So what are the real-time UDP application? This is your GATE question. So multimedia, real-time data transfer, and DNS, TFTP, SNMP, audio and video and speech applications all are going to use what? Even RIP, routing information protocol, is based on your UDP application only. So what are the user datagram format? So it has got, so whenever you are trying to send the data, this data is preceded by your 8-byte header. So your datagram is not going to be numbered, please understand. But in your TCP, every segment is going to be numbered, but in UDP, there is no concept of sequence numbering, because you see that your header does not contain such kind of information. So your 8-byte header, minimum UDP size is 8 byte and maximum UDP size is 65,535 bytes. According to that, this is your 8-byte header. So when I say that 8-byte header, there are only 2 rows only, 2 words, and each word is a 4-byte capability. Therefore, it's a minimum and maximum size of header is 8 bytes only. The first row consists source port number and a destination port number, next a total length, next checksum. These are the 4 important fields. Now I want to explain what are the sequence of system calls are used in UDP. So anyhow, I said that UDP is also using sockets. So what are the sequence of system calls we are using? Sequence of system calls in UDP. It's a quite opposite to your TCP sequence of system calls. If you look at TCP system calls, last class I explained. So this I'm going to write a TCP between client and a server. And the client and server, first of all, they have to understand the socket standards. So naturally we are going to use the Berkeley sockets both for UDP and TCP right now. And now client has to give you connect system call because it's a connection oriented. And the server is going to bind you. And the server is going to listen. And the server is going to accept. Then after that connection is established for you. After that you go for write system call to get the data request. And after that you go for read system call to get the data. But UDP is a different. What is the different? Let me say. So there is a client and there is a server, and both are try to understand the standards of your sockets. And there is no connect system call. Please understand carefully. Because it's a connectionless, so directly it is trying to take a bind system call. Then it is trying to do what? Accept. So now you see, as soon as it is got accepted, then immediately what are we going to do? So receive from and receive to, send to. And this is a send to, and this is a received from, and it can be bidirectionally. Therefore, dear friends, the one of the main important socket function here is only binding. So bind is a very much important, especially for UDP system calls. There is no requirement of what? Connect a system call according to your TCP. Now we are going to see that what are the attributes which are there in your 8-byte header. First word is a source port number. Please stay to the class till the last point. So as usual, it is also going to deal with a port number like TCP only. So the total port numbers which are there, 2 power 16. So every port number is going to consume one sequence number. Port number is 1 byte capability. Now you see 2 power 16 port numbers are nothing but 0 to 65,535 port numbers are there, and they are being differentiated into 3 varieties. One is ephemeral, short-lived one. The other one, well-known port numbers. Naturally, well-known port numbers are being assigned to server only. They are fixed. Therefore, the 0 to 1023 comes under into well-known port numbers. Next one, registered port numbers. what 10242 your 49,151 registered, and your short-lived port numbers are so 19152 your 65,535. So three categories of your port numbers. So according to this is our source port number, which can be in any group like a well-known or a registered or ephemeral. And the same way, destination port number is also 16 bits long. When you talk about the client versus server, please, this is important question. When you talk about the client versus server, server should be given always 0 to 23 port numbers only. Please remember. Whenever server is allocated in this range of sequence number, you can understand that it is server process, not the client process. Client process numbers always will be in the form of 49,152, 65,535. That's why every of your port like HTTP, every of your port like FTP, every of your protocol like SMTP, they are having the numbers during this range. HTTP means 80, FTP means 20 and 21, SMTP means 25, and POP means 109 and 110. So all the servers, so when I am giving a number which is in between 0 to 1023, it is a server process. When I am giving a numbers which is in this group, they are only for what? Client process. Please understand the difference. And next one is a total length. What is a total length? The total length field which is there, the total length field which is there in your UDP header is consist of 16 bit. So you can write 2 power 16 byte because bits will be converted in the form of bytes. So it is 65,536 bytes you can send is a short message, but you see that this is inbuilt having 8 byte UDP header, and your UDP datagrams are encapsulated into IP. So minus 20 byte your internet header. So what is your UDP data size? Your UDP data size is nothing but your IP length minus IP header length, because your UDP datagram is encapsulated into IP. Now let us see, it defines the total length of user datagram, header plus data. The minimum length and maximum length is 8 bytes only. A user datagram encapsulated into an IP datagram according to IPv4 protocol. So total capacity is this much minus 28 bytes header. One is 8 byte UDP header, the other one 20 byte IP header. Now the last variety is a checksum. In TCP also we learned the checksum field. Checksum is optional in UDP. You can leave it this field into zeros, no doubt. But in IP you cannot leave this field as a zeros. Please understand carefully. So in IP you cannot able to leave these values as zeros. In TCP you cannot able to leave these values as zeros, right? But in checksum this is optional, especially in UDP. It's not compulsory and not mandatory. But you want to calculate the checksum, then you're supposed to calculate for three important fields. One is your UDP header, one is Sudo header, the other one data. So the checksum calculation is done if at all you are interested to see that whether your datagram is having errors or not errors, just by calculating, recomputing your checksum value at the other side, receiver side. And checksum is calculated for all the three fields. So the 16-bit checksum field is used for error checking, header and data error checking, UDP header and data padded with initial zeros. And this field is used to detect errors over the entire user datagram, header plus data, and you also include Sudo header also. What is a Sudo header? Because whenever you talk about the socket address, so whenever you talk it about the socket address, and your socket address in TCP and UDP is the same, which I need that IP address is a 32 bits and I need a port number is a 16 bits. This is a mandatory. So this is a mandatory even for UDP as well as TCP. So that's why I need IP addresses. Now the pseudo header comes into the picture. So your pseudo header consists of, your UDP header consists of the following two fields which I told you. One is source port number and destination port number. The other one is a total length. The other one is a checksum. And down you are having your data. And the top you are having, this is your UDP header. This is your UDP data. So UDP data. And the top you are having a pseudo header. This pseudo header we are not going to transmit during data transmission. It is only involved for checksum only. This consists of source IP and this consists of destination IP, and third row is all zeros. So these are the fields which are there in your pseudo header. So in order to know the source IP and destination IP, I should include your pseudo header into the consideration while calculation of checksum. Checksum is a 16-bit length. Initial checksum value is a 16 zeros. So you want to compute the checksum, you also consider these zeros while calculating the checksum. So we calculate the checksum for source IP 2 parts, SIP 16 bits and SIP 16 bits, and DIP 16 bits and DIP another 16 bits, and next word all zeros 16 bits and all zeros 16 bits, and the rest come to the UDP header. So source port number 16 bits, destination port number, total length, and checksum initially 0 values you need to post here, and plus your data bunch which is in the form of what, 16 bit. So all these fields you include while calculating the checksum. After calculating the checksum, you replace these zeros into this particular field, whatever the checksum value you got. So the other side is going to verify whether the packet to be accepted or dropped. If at all checksum is wrong, he is going to be dropped it. Silently he is going to drop. He is not going to give you any kind of acknowledgement because it's acknowledgementless. So this is one of the beautiful example according to Horizon. So the following are the attributes, values which are in hexadecimal format. Which are in hexadecimal format. This is completely belongs to your UDP header only. These are the values of your UDP header. First is a source port, second is a destination port, next is a total length, next is a checksum. You know source port is equal to 16 bits. 16 bits in the sense each one hexadecimal unit is equal to 4-bit combination. Therefore, he is asking what is the source port number, what is the destination port number, what is the total length of user datagram, what is the length of the data, whether this packet is directed to client to server or server to client, what is the client process. These are the questions are raised just by taking these hexadecimal digits. Now listen carefully. When I am talking about source port number is your first field, destination port number next field, and your total length is the next field, checksum is your next field. That means 1, 2, 3, 4. Now one hexadecimal digit is equal to 4-bit combination. So your source port number is a 16 bits. Destination port number is a 16 bits. This is also 16 bits. This is also 16 bits. So you separate them. So I am separating. Your source port number is CB84 because 1 hexadecimal is equal to 4-bit combination. So 16 bits means I have taken 4 hexadecimal digits. And the next field immediately goes to destination port number only. So 16 bits are required. So 4 hexadecimal digits. 000D, it belongs to destination port number. 001C is your total length. And 001C is your checksum. That's it. So you got your answer. What is your answer? Let us cross check. Source port number. Your source port number is nothing but CB84. If you convert, you are going to get this much value. And destination port number 000D, if you convert into decimal, it is going to be 13. And the length of UDP 001C, if you convert into decimal, it's a 28. And the length of the data is nothing but what? Your UDP, total size of your UDP minus your header size. So 8 bytes. So your UDP data is a 20 bytes. And what is the destination port number? The second field is only destination port number. Please understand. So second field is your destination port number. This is a 13. And this is a 52,100. Source port number is a 52,100. So what is the meaning of source port number? Source is nothing but a... Now you tell me which is the server and which is the client. Can anybody answer through comment? So source port number is a 52,100. Destination port is a 13. So now you tell me, is it a client belongs to which port number? Server belongs to which port number? That you need to decide. So servers are always been giving well-known port numbers only. Well-known port numbers means what? The range of well-known port numbers are 0 to 1023. So when I am saying that a destination consists of 13, that means this is your server. And the source port consists of 52,100, which means it is a client. So what do we understand finally? This is destination port number is a 13. Therefore, the client is transmitting the data to the server because client port numbers are always in the form of 49, 152, 65, 535, and your server port numbers are always 0 to 1023. So we confirm that as your source is 52,100, it is a client process, and you're sending a data to client or client to server. That depends on your destination port number. As your destination port number is a 13, then 13 belongs to your well-known port numbers. So therefore, the client is transmitting data to server. This is how you can distinguish whether it is a client process or server process. Then you see UDP services. Very similar services like TCP 1 or 2 or opposite direction. First, it is also one of the responsibilities a process-to-process communication. Nothing but end-to-end transmission. And it's a connectionless. There is a connection-oriented. No flow control. There is a flow control. No error control. Error control. Checksum. There and here it is a common. No congestion control. Congestion control. Encapsulation, decapsulation, multiplexing, demultiplexing are the common properties there and here. So these are the different services of your UDP. Now let us see individual service. When you talk process to process communication, you know, so those who missed TCP process to process communication, now I am explaining, listen, very similar to UDP. So I say application layer is trying to interact with the transport layer with the help of HTTP protocol. That means the client and the server are trying to establish or trying to transmit data using HTTP. That information will be informed to the transport layer. Then transport layer, especially UDP, right now we are working with UDP protocol, cannot work with HTTP, please understand, because HTTP standards are secure. It should be TCP only. Therefore, I cannot use according to this scenario HTTP. So let me change the application layer protocol which is compatible to your UDP. So I am taking SNMP. So I want to see that both are going to communicate using SNMP. So your process, the server module created a process that I want to interact with SNMP. Then immediately it will inform to UDP it is a compatible, right? Then your UDP after transmission of data, here UDP is going to receive it. Then it should hand over exactly to SNMP only. Don't hand over. There are multi other protocols are also there with UDP like DNS and TFTP. Don't hand over this data to other particular processes because you see that this process is being built using SNMP only. So this is a concept of what? Process to process communication or end to end delivery. So UDP provides a process to process communication using a sockets, a combination of IP address and port numbers. And next one is a connectionless service. So there is no concept of a connection here. So no connection establishment and no connection termination, no sign in and no sign out. So each datagram can travel onto a different paths because there is no connection is established. So therefore UDPs are independent but TCPs are dependent. All the next segments are depending on the path which is traversing by first segment. So the user datagrams are not numbered but your segments are being numbered. This is the second responsibility. And there is no relationship between user datagrams. Even they are coming from same source process and going to the same destination program. They are completely what? Independent only. And next one is a flow control. So UDP is a very simple protocol. Internal flow control required, external flow control is not there. Therefore, this is a very important, please underline. There is no window mechanism. Right, there is no window mechanism. But in TCP, sender has to maintain congestion window, receiver has to maintain advertise window, and sender has to send always minimum of CWND, AW. But here there is no concept of window mechanism because there is no concept of what? Flow control. So the receiver may overflow with incoming messages because of lack of flow control. And next one is error control. There is no error control here except the checksum cross verification. So there is no error control mechanism in UDP except for checksum. This means sender does not know if a message has been lost or duplicated. So when the receiver detects an error through checksum, then the user datagram silently discarded. This is the purpose of computation of checksum at the receiver side. If at all checksum is wrongly arrived, then immediately that particular datagram is going to be discarded. And checksum I already told you, so mandatory for a TCP and IP, but not mandatory for UDP. It is optional, but you want to calculate, you can calculate for Sudo header and UDP header and data coming from application layer. So lack of congestion control. Since UDP is a connectionless protocol, it does not provide any kind of a congestion control. but in TCP we are having external AIMD algorithm. So using AIMD algorithm, you can able to control the congestion using a flow control policy and network control policy. Why there is no congestion control here? Because UDP assumes that my messages are only shorter, not longer. No bulk data, very minute amount of data, then why you guess the congestion concept? That's why UDP assumes that the packets are sending are very small in size and cannot create any congestion in the network because it's a smaller, it's not a bulk data. Yes, friend. So almost all I'm dealing all topics, and please attend every special class also. Download Unacademy Student Learning app. There I am doing special classes on same areas. Please watch them. So encapsulation. So what is the meaning of encapsulation? Attaching of headers, and decapsulation, detaching of headers. This is the common property between your TCP and UDP. So when a process has a message to send through UDP, it passes message through UDP along with the pair of socket addresses and the length of data. And this is being covered with the UDP header. Then UDP passes that particular datagram to IP. Then IP is going to attach an IP header. IP is going to add its own header. Then when data comes to the next data link layer is also going to add its own header and a trailer. So this is the concept is called as what? Encapsulation. But don't forget the IP is taking a number as a what? 17. I already explained in the IP layer concept. If for example, let us say transport layer data is coming to internet layer, and if I am saying that my protocol number is equal to 6, that means internet layer understand that you are sending the data through TCP, not UDP. You want to send the data through UDP, then transport layer has to change this protocol number to something like 17. And when I say 17, then you are trying to interact with what? UDP. So the protocol numbers are vary. TCP means it's a 6 and protocol number 17 means it is a what? UDP. And the next one is a decapsulation. So detaching of headers and trailers till it reaches to exact application layer program. So when the message arrives at the destination host, the physical layer decodes, data link layer removes the header and trailer, and IP layer is also removes the header if there are no errors in the checksum. And finally, UDP is also going to remove your header and your data is going to be transmitted to your application layer. And queuing. So in UDP, queues are associated with the ports. At the client side, when a process starts, it requests a port number from the operating system. Because a client port numbers, we know that it is a 149, 152, 65, 535. So therefore, some implementations create both incoming and outgoing queues associated with each process. Now next one is what? Multiplexing. What is a multiplexing? However, TCP is operating with the different kinds of protocols at a time. So for example, TCP can run with HTTP and TCP can run with SMTP and TCP can run with FTP, and here also TCP can able to deal with all these three protocols and many. However, if TCP is dealing it, UDP is also dealing the same. So for example, let us say application layer is created three processes. One process in the favor of TFTP and one process in the favor of SNMP and one process in the form of NNTP. So three processes are coming from client and they want to interact the same with the server. So they have to be reverse. So server side application layer. So you need to hand over to application layer all the three respective processes. So one is a TFTP, and the other one same process SNMP, and the other one network news protocol. Now you see, but UDP is only one, please understand. However, TCP is a one, UDP is also one. Now the beauty of your UDP and TCP are, they are alone, but they can able to take one to many connections and handing over many to one connections, please understand. So I'm taking a many of your client process as a one UDP, and while handing over the data, I can able to do many. So exactly the TFTP is going to demux to TFTP only, and this UDP is just a handover to SNMP because second process is SNMP, and next it is a what? NNTP. So this is the concept of muxing, and this is the concept of demuxing, logical multiplexing and logical demultiplexing. So what is a multiplexing? At the center side, there may be several processes that need to send user datagrams. But however, there is only one UDP I said. So many to one we take. Many to one is the concept of muxing. And while delivering the data to other side, according to the socket address, according to the port number, according to the protocol standard, you need to hand over the data to different processes on the same standards. Then UDP passes the user datagram. So what is the demultiplexing? At the receiver side, there is only one UDP, but it try to hand over to multiple applications. So that's why one to many relationship, one UDP, but it served to multiple number of upper layer protocols of application layer. So this is the concept of multiplexing and demultiplexing. So this is the idea, friends. So many processes are coming, and logically I'm going to combine them. Then it comes to the IP, and IP deliver them. It goes to the UDP, and it is going to give you the same standard. So this is related to this process, and this is related to this process, and this is related to this process. This is related to this process. So everything is same to same according to TCP. But if anybody asks you in the campus interviews, they used to ask this question: can you differentiate why the importance of UDP? Yes. When you want to transmit a short amount of data in a quick time, very faster time, then you believe in UDP because connection establishment is a mandatory in TCP. And UDPs are faster and dynamic and lightweight because of only 8-byte header. But TCP, you can extend your header size from 20 byte to 60 byte. This is one of the major drawback in TCP. So that's why some of the most of the application protocols like multimedia, real-time, audio, video, speech applications, they are all comes under into what? UDP, where we want to see that a small amount of waiting time, but a huge amount of data you want to transfer. That's why we people always prefer, when you want to do broadcasting and when you want to prefer multicasting, better you prefer for UDP applications, not the TCP. So what is the objective of entire today's session? The objective of entire today's session is nothing but some of the application layer protocols securely they are dealing with TCP, and some of the application layer protocols faster they prefer what? UDP. Security concern prefer UDP, faster concern prefer UDP. So remaining same to same, as it is a connectionless, then you see that some of the drawbacks are there which we are already highlighted. What are the drawbacks? No flow control, no congestion control, no error control, no acknowledgement system. These are all there with the UDP. That's why TCP for connection oriented networks. UDP is a connectionless networks. So some people will say that Can I use in a wireless transmission this UDP? Yes, you can use in the wireless transmission this UDP transmissions. So that's it, my dear friends. In the next class, we will see the another responsibility of TCP, that is error control. So after that, we are going to see some of the application layer protocols with some cryptography functionalities. Stay tuned to Unacademy, and still you want to learn much more in-depth learning, because computer networks is three subjects: basic networks, and your computer networks, and advanced computer networks. So I'm going to start a new plus course, so maybe from 10th December. So if you want in-depth knowledge, so many things I'm going to discuss in the plus program apart from your free content. Please join into Unacademy immediately and see that you're going to get the in-depth training. Stay tuned to Unacademy, stay tuned to my classes. Please share all this knowledge to with all your friends, those who are studying current third year, those who are studying computer network subject and DBMS and operating system lectures. Please do like and give a positive comment, because your comment is going to give a lot of boost to me so that I can able to prepare good content. Thank you very much.